So next, we are going to evaluate the geometric series. If we cannot find the value, we just state that it diverges. As you noticed, this is the infinite series since you don't have the finite number or the finite sum or the index of the k here starting from 0 to infinity. This is infinite series of the geometric series. So to find the value of this geometric series, we're gonna have to identify the A or the first term again, the R or the ratio or the common, the constant number that multiply to obtain the next term. And from the theorem that the absolute value of the R less than 1, so the R to the power n approaches 0. If the absolute value of the R is greater than 1, then the R to the power n approaches infinity. Absolute value of the R equals 1. Then the R to the power n approaches 1. And these three cases gonna help you identify whether this geometric series converges or diverges. If the R to the power n approaches 0, so this one gonna tell us that the geometric series converges. And the other case is diverges. So from our case, the A, which is the first term, or when k is 0, which is negative 2 over 3 to the power 0 or 1, and r is a number that raised to the power of the k. In this case, the r is negative 2 over 3. For r equals negative 2 over 3, we know that the absolute value of the r is less than 1. So then the series k equals 0 to infinity of negative 2 over 3 to the power k can be derived as a divided by 1 minus r, or this one is the convergence case. Okay, in our case, the a is 1, the r is negative 2 over 3. Simplify the numbers as 1 divided by 1 plus 2 over 3, or 1 divided by 5 over 3. And we write it as the non-complex fraction form or the reciprocal of 5 over 3 to get 3 over 5 as the value of this geometric series. Or we can say that the series converges to the value 3 over 5. Next example, we have the geometric series as the sigma notation of the 5 multiplied by 1 over pi to the power 2k, and k starting from 2 to infinity. Let's make a list again. A is the first term, or when k equals 2, going to be 5 multiplied by 1 over pi to the power 2 times 2, or 5 divided by pi to the fourth as the first term. And the r is the number that raised to the power k. So rewrite this series a little bit into the form of the sigma notation, 5 times pi 1 over pi to the second and all to the power k. So therefore, we can see the r as 1 over pi to the second. Okay, and with these two numbers, we use the r to identify whether this series gonna converge or diverge. Since the r equals 1 over pi squared, so then the absolute value of the r is less than 1. So we know this series will converge to the certain number, to the one real number. Therefore, we're gonna use the formula as the series 5 times 1 over pi to the power 2k, k from 2 to infinity equals a divided by 1 minus r. And the a is 5 over pi to the fourth power divided by 1 minus r, which is 1 over pi to the second. and simplify this term to get 5 over pi to the fourth divided by pi squared minus 1 over pi squared, and then rewrite it into the fraction form as 5 pi to the second divided by pi to the fourth multiplied by pi squared minus 1. Simplify one more time. Pi squared and pi to the fourth reduce. So then this series converges to the value 5 divided by pi squared multiplied by pi squared minus 1. So converges to this value. This example, we have the series of 2 to the power k minus 1 divided by 5 to the power k minus 1. First of all, just rewrite the an term here in the form of something raised to the power k. So we have sigma notation. This is 2 to the power k times 2 to the negative first for the numerator. And denominator, similar way, apply the exponent property as 5 to the power k times 5 to the first power. And rearrange it as 2 to the negative first over 5 to the first multiplied by 2 over 5 sharing the same power k. K starting from 1 to infinity. And one more time, 2 to the negative first is the same as 1 over 2. Therefore, we have the sigma notation of 1 over 10 multiplied by the quantity 2 over 5 to the power k, k from 1 to infinity. With this form, we can identify the a for the first term as k starting from 1. So the first term, when k equals 1, is 1 over 10 multiplied by 2 over 5 to the first power, which gives us 2 over 50 or 1 over 25 as the first term, and r as the ratio number or the constant multiple to obtain the next term, which is the number that raised to the power k. So in this case, the r is 2 over 5. Again, the absolute value of the r is less than 1. So then the series or the geometric series k equals 1 to infinity of 2 to the k minus 1 over 5 to the k plus 1 can be computed as a divided by 1 minus r. And our a is 1 over 25 divided by the 1 minus r as 1 minus 2 over 5. And simplify the numbers as 1 over 25 divided by 5 minus 3 is 5 minus 2 is 3, so 3 over 5. Simplify one more time to get 1 over 15 as a result. Or we can say that the series converges to the value 1 over 15.